Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a 3D isometric projection of an engineering object into which the front view face, the top view face and the right hand side view face of the solid, they have been appropriately combined into a single 3D isometric projection. Now using the information available with us regarding the constructional details of this engineering object through this 3D isometric projection, we are required to obtain the front view orthographic projections, the top view orthographic projections and the right hand side view orthographic projections of the solid. So in order to obtain the orthographic projections of the solid, we need to obtain the dimensions of the front view face, the top view face and the right hand side view face of the solid. Now when the observer is going to look at the solid from the front view orientation, so we observe that the width of the solid happens to be equal to 120 millimeter, while the height of the solid it is equal to 40 millimeter plus 10 millimeter, it is equal to 50 millimeter. So here we have got the dimensions of the front view face of the solid measuring 120 millimeter width by 50 millimeter height of the solid. When we are going to look at the solid from the top view orientation, so we observe that width of the solid happens to be 120 millimeter, while the depth of the solid happens to be equal to 70 millimeter. So the top view face of the solid will be measuring 120 millimeter width by 70 millimeter depth of the solid over here. Now when we look at the solid from the right hand side view orientation, we observe that the depth of the solid happens to be 70 millimeter, while the height of the solid it is equal to 50 millimeter. Therefore, the side view face of the solid will be bearing 70 millimeter depth and 50 millimeter height of the solid. Let us proceed to evaluate orthographic projections of the solid. So in order to obtain the orthographic projections of the solid, we have drawn the XY reference line, we have drawn the X1, Y1 reference line, and we have also obtained the transfer line which is originating from the intersection point of the XY reference line and the X1, Y1 reference line, and this transfer line happens to be inclined with respect to the XY reference line at an angle of inclination of 45 degree over here, and this transfer line we are going to utilize in order to transfer the distances alongside the depth of the solid from the top view orthographic projections into the right hand side view projections over here. Now since we are required to obtain the orthographic projections of the solid into the first angle projection method, therefore the front view orthographic projections will be obtained above the XY reference line, the top view orthographic projections of the solid will be obtained below the XY reference line, and the right hand side view orthographic projections of the solid will be obtained on the left hand side of the front view orthographic projections above the XY reference line. Now we know that the front view face of the solid, it is having dimensions 120 millimeter width and 50 millimeter height over here. So now we have to draw two vertical projector lines into the front view orthographic projections which are separated by a distance of 120 millimeter, which is equal to the width of the solid. This is the width of the solid equal to 120 millimeter, and these two vertical projector lines we have appropriately extended them into the top view orthographic projections over here, because we are going to require the width of the solid equal to 120 millimeter into the top view projections over here. Now we know that the height of the solid, it is equal to 50 millimeter. So now we are going to obtain a horizontal projector line into the front view orthographic projections at a height of 50 millimeter above the XY reference line. And this horizontal projector line, we have appropriately extended it into the right hand side view orthographic projections as well, because into the right hand side view orthographic projections also we are going to require the height of the solid equal to 50 millimeter. Now we know that the top view face of the solid, it measures 120 millimeter width and 70 millimeter depth of the solid. So 120 millimeter width of the top face we have already obtained by extending these two vertical projector lines from the front view orthographic projections into the top view orthographic projection view over here. Now we have to draw two horizontal projector lines into the top view orthographic projections separated by a distance of 70 millimeter, which happens to be the depth of the solid. So here we have been provided with depth of the solid equal to 70 millimeter, and these two horizontal projector lines we have appropriately transferred into the right hand side view projections over here using this transfer line. So now we can check this depth equal to 70 millimeter has been appropriately transferred into the right hand side view projections over here. And now we have obtained the right hand side view face of the solid measuring 70 millimeter width and 50 millimeter height of the solid over here. So now let us proceed with evaluation of front view orthographic projections of the solid. So now we can divide the solid into four elements. Element number 1, it is a horizontal wave which is having height is equal to 10 millimeter, and this horizontal wave, it is resting onto the ground. Now the element number 2, it is a vertical hollow cylinder having outer diameter 60 millimeter, inner diameter 40 millimeter, which is resting centrally on top of this horizontal web over here. Then element number 3, we have got two inclined perpendicular webs over here which are used to support this vertical hollow cylinder, and this vertical hollow cylinder is required to hold a vertical shaft over here. And now here we have got again a cylindrical hole over here into this vertical cylinder, which is our element number 4 over here, and through this we are going to pass out a snug through this wall of the cylinder so that we can tightly secure or hold a shaft into this hollow cylinder over here. So now we are going to evaluate different elements of this engineering construction alongside the width of the solid into the front view orthographic projections over here. So now we know that this vertical hollow cylinder, it is resting centrally on top of this horizontal wave. Now we are going to take a distance of 60 millimeter from the right hand side face of the solid so that the center point of this vertical hollow cylinder, which is resting centrally on top of this horizontal wave, can be located over here. Now a center vertical projector line has been located into the front view projections, and the center vertical projector line has been appropriately extended into the top view projections over here. Now we know that this hollow cylinder, it is having internal diameter of 40 millimeter. So from the center point, now we have to locate these two end points of the diameter into the front view orthographic projection over here. So now from the center point, we have to take an offset of 20 millimeter towards the left surface of the solid, and 20 millimeter offset has to be taken towards the right hand side surface of the solid. So now two vertical black projector lines indicating the internal diameter of this vertical cylindrical element number 2 over here, they have been located into the front view orthographic projections, and these two vertical black projector lines, we have appropriately extended them into the top view projections as well. Similarly, we know that corresponding to this vertical hollow cylinder, we have got outer diameter of 60 millimeter. So in order to locate these two end points of the diameter, we have to take an offset of 30 millimeter towards the left side surface of the solid and 30 millimeter offset towards the right hand side face of the solid over here. So now from the center point, we are going to take offset of 30 millimeter toward the left side and 30 millimeter towards the right hand side, so that two vertical black projector lines representing the outer boundary of this vertical hollow cylinder, they have been obtained into the front view projections, and these two black vertical projector lines, we have appropriately extended them into the top view projections as well. So this way we have been able to locate internal diameter endpoints and external diameter endpoints corresponding to this vertical hollow cylinder, which is our element number 1. Now we also know that corresponding to this cylindrical element over here, which is going to carry a snug, which is going to have a screw over here, so that we can secure the shaft within this hollow cylinder. So here we have got corresponding to this element number 4, that is another very short cylindrical element over here, which is an external cylindrical element. Here we have got the internal diameter of this hollow short cylinder equal to 10 millimeter, and here we have got external diameter of the short cylinder as 20 millimeter, right? So this way now we have to take offset of 5 millimeter onto the left side and an offset of 5 millimeter, so that these two end points of the short cylinder can be located into the front view orthographic projections over here. Similarly, corresponding to this outer diameter of this short cylindrical element over here, we have got diameter is equal to 20 millimeter. So now we will be taking an offset of 10 millimeter towards the left hand side and 10 millimeter towards the right hand side. So again, two vertical black projector lines we have obtained into the front view projections, and all of these four vertical black projector lines, we have appropriately extended them into the top view orthographic projections over here. So this way all the elements of the solid alongside the width, they have been appropriately defined. Now let us define all the elements of the solid alongside the height of the solid. So we know that the height of the horizontal web, which is element number 1, it happens to be 10 millimeter. So we have taken a distance of 10 millimeter from the base, and we have obtained a horizontal projector line into the front view projections, and we have appropriately extended this horizontal projector line into the right hand side view orthographic projections over here. Now this short cylindrical element, it is also located centrally onto this vertical height of 40 millimeter. So now we have to measure a distance of 20 millimeter from the top surface of this horizontal wave, so that the center point corresponding to this short circular hollow cylinder can be obtained into the front view orthographic projection. Now here we have obtained a horizontal center projector line into the front view orthographic projections, and we have extended this center projection line into the right hand side view orthographic projections over here. Now let us start darkening the surfaces which are visible to the observer from the front view orientation. So as the observer is going to look at the solid from the front side, so this flat vertical surface which is lying towards the front side of the solid, so this surface will be parallel to the vertical plane, and this surface will be projected as true shape projection into the front view orthographic projections over here. Next we have got the element number 2, which is a hollow cylinder having outer diameter of 60 millimeter. So now corresponding to this outer diameter 60 millimeter, so this circular outer portion of the cylinder, it will be represented as apparent shape rectangular projections into the front view orthographic projections over here, whereas the inner portion of this hollow cylinder, it will not be visible to the observer from the front view orientation. So we are going to get dotted line or hidden line projections corresponding to this diameter of 40 millimeter. Here we have got the hidden line or the dotted line projections corresponding to the interior surface of this hollow cylinder, appearing as apparent shape rectangular projections over here. And now we can check this hole, it is going up to the bottom surface of this particular object over here. Now corresponding to element number 3, here we have got two triangular webs over here, one on either side of this hollow vertical cylinder over here. Now since these two triangular surfaces corresponding to element number 3, they happen to be parallel to the vertical plane, so the true shape projections corresponding to these two triangular webs, they will be obtained into the front view orthographic projections over here. Next we have got this short cylinder, right? So corresponding to the short cylinder, we know that internal diameter is 10 millimeter and external diameter happens to be 20 millimeter. So here we have obtained the internal diameter of 10 millimeter corresponding to this circular projection which we have obtained over here, and the true shape circular projection will be visible to us into the front view orthographic projection. And the moment we obtain this 10 millimeter circular projection as a true shape projection into the front view orthographic projections, now two horizontal black projector lines with an offset of 5 millimeter on either side of the center line we have to draw into the front view orthographic projections, and these two horizontal projector lines we have appropriately transferred them into the right hand side view orthographic projection view over here. Similarly, corresponding to the outer portion of the short cylinder which is going to carry a snug, now we know that the diameter of the outer portion of the cylinder, it is equal to 20 millimeter. So now with 10 millimeter radius from the center, now we have drawn a true shape projection corresponding to the outer part of the short cylinder over here into the front view projections, and now two horizontal black projector lines we have to draw with an offset of 10 millimeter towards the upper surface side and 10 millimeter offset towards the base of the solid, and these two horizontal projector lines we have to appropriately transfer them into the right hand side view projections over here. Now let us proceed to evaluate top view orthographic projections of the solid. Now we know that this hollow vertical cylindrical portion, that is our element number 2, it is lying centrally alongside the depth of the solid also. So the total depth of the solid is available with us as 70 millimeter. So the midpoint or the center point will be 35 millimeter from the front surface or 35 millimeter from the rear surface of the solid. So from the rear surface of the solid we have taken a distance of 35 millimeter and we have obtained a horizontal center projection line into the top view projections, and we have transferred the center projector line into the right hand side view projections using this transfer line over here. Now having obtained the center point corresponding to this hollow cylindrical object, now we also know that this vertical triangular web, it is also lying centrally alongside the depth of the solid. Now this inclined triangular web, it is having depth is equal to 10 millimeter. So from the center line we have to take an offset of 5 millimeter toward the rear surface and 5 millimeter toward the front surface of the solid, so that this depth of the triangular inclined web, one is lying on the front side, another triangular web is lying toward the rear side of the solid. It can be obtained into the top view projections over here, and here we have obtained two horizontal projector lines into the top view projections, and using this transfer line we have appropriately transferred these two horizontal projector lines into the right hand side view projections over here. Now next we have got this outer portion of this hollow cylinder, that is diameter is equal to 60 millimeter. Now we have to take this center point using radius is equal to 30 millimeter. Now we have to draw a circle having diameter equal to 60 millimeter, which will be denoting the true shape of the outer portion of this hollow cylinder over here. Now once we obtain the outer portion of this vertical hollow cylinder over here, now we have to draw two black horizontal projector lines with an offset of 30 millimeter toward the rear surface and offset of 30 millimeter towards the front surface of the solid. And these two horizontal black projector lines we have appropriately obtained into the top view projections, and now using this transfer line we have appropriately transferred these two black vertical projector lines corresponding to the outer portion of this hollow vertical cylinder into the right hand side view projections over here. Now next we know that corresponding to this internal diameter of this hollow cylinder having diameter is equal to 40 millimeter, using this center point we have to take a radius of 20 millimeter, draw this internal diameter of the hollow cylinder over here having diameter equal to 40 millimeter, and once again we are going to obtain the true shape projection corresponding to the internal diameter of this hollow cylinder over here. And the moment we obtain this true shape of the internal diameter of the hollow cylinder, once again two horizontal black projector lines which are separated by a distance of 40 millimeter in such a way that we have to take an offset of 20 millimeter from the center line toward the rear surface of the solid and an offset of 20 millimeter towards the front surface of the solid. So now we have obtained these two horizontal projector lines into the top view projections, and now using this transfer line we have appropriately transferred these two end points of the internal diameter of the hollow cylinder into the right hand side view projections over here. So it is these two end points now that we are talking about. So these two end points, they are located over here. Similarly, these two end points of the hollow cylinder, they are located over here. So this way the cylinder projections, they have been obtained into the top view projection, and this surface, this will be represented as true shape projection into the top view projections over here. So this is the true shape representation of the top surface of the hollow cylinder. And also, since this horizontal wave, it happens to be parallel to the horizontal plane, so we have been able to obtain the true shape projections corresponding to the horizontal wave onto the horizontal plane available over here. Next we have got these two triangular inclined webs over here. Because the top surface of these inclined triangular webs, they happen to be inclined with respect to the horizontal plane. So into the top view projections we have been able to obtain apparent shape projections of these inclined webs into the top view projections over here. And finally here we have got a short cylinder having depth is equal to 3 millimeter. So it's an external cylinder. So now we have to take a distance of 3 millimeter from this black projector line towards the front surface, and corresponding to this external diameter of 20 millimeter. So we have to draw this short cylinder over here. So this dimension is 3 millimeter and this dimension is 20 millimeter. And now we can check, as we are going to add a snug through this hollow part over here. So there will be a hole into this cylinder in front of this particular short cylinder. So here we have got a hollow cylinder over here. Because this hollow part of the cylinder, it will not be visible to the observer from the top. So this hollow part will be having diameter is equal to 10 millimeter. So corresponding to this hollow part, a hidden line projections we have been able to obtain into the top view projections over here. Now we can see that corresponding to this outer portion of the surface of this short cylinder, which is having depth is equal to 3 millimeter. Now a horizontal projector line we are going to obtain into the front view orthographic projections. Now we can see distance between this black projector line and this horizontal projector line will be 3 millimeter, because this depth of the short external cylinder happens to be 3 millimeter over here. So a horizontal projector line has been obtained into the top view projections, and this horizontal projector line has been appropriately transferred using this transfer line into the right hand side view projections over here. So with this we have been able to obtain the top view orthographic projections of this object. Now let us proceed to evaluate the right hand side view orthographic projections of the solid. So when the observer is going to look at the solid from the right hand side view orientation, so this right hand side surface corresponding to element number 1, that is a horizontal wave which is available at the base. So this surface will be parallel to the profile plane. So we are able to observe true shape projection corresponding to this surface onto the profile plane into the right hand side view projections over here. Next we have got corresponding to this element number 2, that is a hollow vertical cylinder outer portion which is having diameter is equal to 60 millimeter. So a apparent shape rectangular projections corresponding to the external part of the cylinder will be visible to the observer. So we are going to obtain apparent shape rectangular projections corresponding to the cylindrical outer surface of this hollow vertical cylinder into the right hand side view projections over here. And from the right hand side view, this internal diameter, it will not be visible to the observer, having diameter is equal to 40 millimeter. So now we are going to obtain the dotted line projections over here into the right hand side view projection. So once again, an apparent shape rectangular projections will be available with us into the right hand side view projections over here. Next we have got this inclined triangular web over here. So this inclined triangular web, it is not parallel to the profile plane. So we are going to observe the foreshortened projection of this inclined surface into the right hand side view projections over here. And finally, corresponding to this element number 4, here we are going to get a small projection over here. Now this outer diameter, it is 20 millimeter and the internal diameter has to be 10 millimeter. So a hollow part we have to obtain over here so that a snug can enter from this side. So here a hole will be there into the cylinder having diameter is equal to 10 millimeter. So this way we have been able to obtain the right hand side view orthographic projections of the solid. Now we have discussed the procedure, how do we evaluate front view orthographic projections, top view orthographic projections, the right hand side view orthographic projections of a solid, when the 3D isometric projection of a solid depicting the constructional details of the solid, it is available with us. So this is all for today. So we are going to continue with further discussion regarding few more illustrative cases of orthographic projections of the solids in the coming lectures. So thank you very much. Thanks a lot.